Hello friends, welcome to my YouTube channel Notes Wali. In this video I am back with the notes of the chapter belonging to chemistry class 11, that is the P block elements. The link for accessing the PDF of notes is available in the description box. Go and check now. As the previous video of S block elements, I have not written these notes myself, but these are very excellent notes and you must read them carefully. You will surely get all the points. So friends, let's have a look at the main concepts of the chapter. So from the name of the chapter we know that this chapter is about the P block elements. The P block mainly comprises of the group 13 to 18 of the modern periodic table. So again, like S block, we will firstly see the notes and important points of this chapter, and at the end we will look at the important questions from the examination point of view. And the P block elements are defined by the elements whose last electron enters in any of the p orbital of their outermost shell are called P block elements, and their general electronic configuration of outer shell is ns2 np 1 to 6. The group 13 starts from boron, which is referred to as boron family, group 14 which is carbon family, group 15 which is nitrogen family, which is also known as niconides, and group 16 oxygen family, which is referred to as chalcogens because these elements generally cause cancer. And ore forming elements, group number 17 is halogen family, starts from fluorine, and group 18 noble gas elements. So firstly, talking about the group 13, that is the boron family, and its outermost electronic configuration is ns2 np1, and boron shows diagonal relationship with silicon. Both are semiconductor or metalloids and form covalent compounds. The covalent compounds of this group are electron deficient because incomplete octet of the central atom. Simplest boron hydride is B2H6, which is known as diboron. Boron oxide is acidic in nature and it reacts readily with the water to form boric acid. Nextly, there is aluminium. Aluminium compounds are mostly covalent and the oxide of aluminium is amphoteric in nature. The aluminium halides are also electron deficient and they act as Lewis acid by accepting lone pairs from Lewis bases. You can see this table is about the group 13 elements, electronic configuration and other physical properties. As we know that on going towards right from the left in the period, atomic and ionic size decreases. Their first ionization enthalpy is very less as compared to the alkaline earth metals. These elements are electropositive or metallic in character. The elements of this group shows variable oxidation states and the most common are +3 and +1. You can see the structure of diboron, and the second diagram shows the bond angle and the bond length. Now comes some important characteristics of borans. The lower borans are colorless gases while the higher borans are volatile liquids or solids. Volatile means the substance which is having a low melting point. Borans undergo spontaneous combustion in air due to strong affinity of boron for oxygen, and borans react with alkali metal hydrides. Diboron reacts with ammonia to give borazine at 450 Kelvin. The borazine has a cyclic structure which is similar to the benzene and thus it is called inorganic benzene. It is a very important question for 1 mark or MCQs. The aluminium hydride is colorless solid polymerized bridging unit, and these hydrides work as Lewis acids which are very weak. Now comes the oxide and hydroxides. As we go down the group, the hydroxide acquires the basic character. You can see the structure of boron trihalide, and nextly there is the dimeric structure of aluminium chloride. Structures that I am showing are very important from examination point of view. You should remember them and also revise thoroughly from your textbooks. And lastly, there are anomalous properties of boron because we know that the first element of every group behaves anomalously, and boron exists in two forms, that is crystalline and amorphous, which we'll be learning in the class 12 first chapter, the solid state. But aluminium does not exist in different forms. Basically the crystalline form is in which the atoms or the constituent particles form different geometrical and regular crystal, whereas in amorphous the arrangement of constituent particles is irregular. Boron forms only covalent compounds, but the aluminium forms some ionic compounds like aluminium hydroxide. Now we come to the group 14 elements known as carbon family, which is the foundation of our organic chemistry. The general electronic configuration is NS2-NP2. The ionization enthalpy of these group elements are higher than that of group 13 elements. They are more electronegative than group 13 elements. Then come to chemical properties, and carbon and silicon mostly show +4 oxidation state, but germanium forms stable compounds in +4 state, and in some compounds it has oxidation state of +2. Except carbon tetrachloride, all the other tetrachlorides are easily hydrolyzed by water because carbon tetrachloride is almost non-polar. As the carbon does not have d orbital, so it cannot expand its coordination beyond the number 4. Carbon has 3 types of allotropes that we have already studied in class 10, that are graphite, diamond and Buckminster fullerene. You all know their physical properties very well, so we need not to discuss here. Nextly, we come to some important compounds of carbon and silicon. Carbon forms mainly two oxides, carbon monoxide and carbon dioxide. Then there is laboratory method of preparing carbon dioxide, which is prepared by the treatment of dilute HCl with calcium carbonate. Silicon dioxide is again a covalent three-dimensional network solid. Next is zeolite. Zeolite is an aluminosilicate of metal, and we have also studied its formula in the chapter hydrogen, where we used it to remove the permanent hardness of water. And now we come to the most important part of the chapter, that are the questions, which will help you to know how the questions are asked in exam and what form they take. First part comprises of 1 mark question. First question is, why is boron used in nuclear reactions? And the answer is because boron can absorb neutrons, so it is widely used in the nuclear reactions. And now comes the next question, which is we have to show that boron hydroxide behaves as an acid in water, and here comes the concept of our Bronsted-Lowry acid-base concept, which you have to use. Then the question is, what is producer gas? Producer gas is actually the mixture of carbon monoxide and nitrogen in the ratio of 2:1. And I have told you the shortcut to find the hybridization of any element by 2 shortcut methods in chapter number 4, chemical bonding. You have to go there and learn how to find out the state of hybridization for any element. So you have to find the hybridization state of B in BF3 and in BH4 negative. So let's discuss 2 marks questions. So first question is the reason based, where you have to give the explanation for the given conditions. Second question is reaction based, and third question is again reason based, and the question now is suggest a reason to prove that why carbon monoxide is poisonous. We have been studying this from junior classes, so you must know it. Next question is, what do you understand by allotropy and inert pair effect? Inert pair effect is a very important definition of this chapter, and this says that sometimes the valence shell electron pair does not participate in the bond formation, which is called the inert pair effect, and due to this inert pair effect the oxidation states vary, especially in the p block. And allotropes are the different structural forms of an element. Next question is regarding our environment, and it can be said a value based question. So the question is, how is the excessive content of CO2 responsible for global warming? Next question is, give 2 similarities and 2 dissimilarities between boron and aluminium that we have discussed a while ago. Next question, what are fullerenes and how they were prepared? So you have to read this carefully. The 3 marks question are again reason based or explanation based. You can see that there's again a question of drawing the structure. As I have told you earlier, the structures are very important and you must practice them. Now comes the 5 marks question. The first question is given in the parts and we have to explain the formation of water gas and producer gas, also give their uses, and the next part is what happens when CO2 is passed through lime water for short duration and for long duration. We know that for short duration it turns milky and produces the calcium carbonate, whereas in the long duration passing of carbon dioxide it turns into calcium bicarbonate. The next question is, why do boron halides form addition compounds with ammonia? We know that boron halides are electron deficient and ammonia is electron rich, so it forms addition compound with it. Next question, we have to give the reasons. If you have read the chapter very carefully, you will be able to answer these questions. So friends, that's all for this video. We will meet in the next video with the notes of chapter hydrocarbons. Don't forget to like, share and subscribe the channel. Thank you. Bye bye.